Hey, it's Mike Waters and welcome back to the Mystic Smoker Shop. In this episode, we're going to do basically an appendix to a previous video that I did several years ago, namely the Firebox Joinery video, where we added the 24-inch by 30 by 3/8 wall firebox, exactly like this one here, to a 250-gallon tank. There were a few things that I left out in that video and a few things that I have changed the way that I do since then. Namely, at this point I'm using a self-leveling laser to do the layout and to make sure that I get my tank perfectly lined up. There's absolutely nothing wrong with the way that I did it before, which is the plumb bob method, where essentially I would hang a plumb bob out here and be able to control that vertical alignment by using a plumb bob hanging from the string. In my opinion, that's still an extremely viable way to accomplish what we need to do. But, you know, in the times of new technology, this is a little bit quicker, as long as you understand that there are some errors that you can induce by using a self-leveling laser. Alignment is a little trickier using the self-leveling laser than using the plumb bob. In other words, once you line that plumb bob up and you drop that string, things don't change. You can bump this very easily. You can get it misaligned just a tiny bit and not know it unless you know exactly what to be looking for. So in this video, that's one of the things we're going to talk about, is using the newer technology that is so cheap nowadays. When I did that previous video, these rascals were like 300 bucks, and it was difficult for guys to swing that just for 2 or 3 cooker builds or maybe even a single. But now you can get a self-leveling laser for, you know, $50 to $100 at one of the big box stores and do just fine. I have one that I picked up at one of the big box stores. A brief tip, mine comes in a nice carry case and it's got 2 or 3 little adapters and brackets and stuff like that that absolutely I never use. I put mine on a tripod. I'll make sure we get a shot of that here. Just a cheap tripod, $5 tripod that I found at a yard sale, and it does fabulously. It lets me adjust it vertically and it's easy to move it around. I don't use those other brackets is my point. So they sell them in kits that have just the unit itself, or all of those brackets and everything else, including the carry case. And in my opinion, I wish I'd have saved the money on the carry case and all those other things, because honestly, I never have touched them. But let's move forward and move straight into the layout phase of our build. And like I said, we're not going to cover the entire video, the Firebox Joinery video, because there was an awful lot of good information in there, and a lot of that information still stands. So in our layout video, we put a horizontal line basically all the way around our tank, and that's the line that we will work from in this case. Now, I have leveled this tank on the build table, and if you're not using a build table, at some point I would recommend make a build table of something. This one is just made out of some scrap steel that I had actually on another piece of equipment that I retired several years ago, and I chopped it up and made this build table out of it. I have gotten plenty of short video clips and photographs over the years of guys build tables, you know, budget build tables and that sort of stuff. I will be putting a folder together on the Mystic Smokers website, mysticsmokers.com website, here in the near future, with a lot of these photographs on there, so that if you can't build a nice build table, which this is probably, I don't know, my 6th or 7th version of a build table, and every time that I build another one, I change something, tweak it. So this is the latest version that I have out, and there's a video on this. But my point is, if you don't have the resources at this stage, or don't want to spend the time to build an elaborate build table, then I will have photographs of ideas that guys have come up with, you know, like from using 6x6s or 8x8s. And I saw one really cool idea where a guy had taken a stack of pallets and sheathed that essentially with plywood, you know, screwing it all together where it was nice and stable, and then just put some casters, some cheap casters on top of that. And that worked just fine for him. This table here always has a tank on it. It never goes a single day without having at least a tank on it. So I needed something a little more sturdy and robust. that could work every day. So I have gone ahead and leveled this tank completely. It is 100% level from one side to the other, and that is extremely important whenever we're attaching the firebox or attaching the collector or even putting the grates in. Those three things, you want to make sure that your tank is exactly level and is exactly clocked. Now, this, in my opinion, is invaluable. They're pretty cheap. This one happens to be what's called a Flange Wizard brand. It's just, you know, when I bought mine, that's what had the highest ratings and all of that business. And it has been a very, very important tool in my shop. They're pretty cheap. You can Amazon or wherever else you want to get it. There are different brands out there. You know, I'm not loyal to Flange Wizard other than the darn thing's rock solid. And I have used it for years. And you've got to have something, and again, there are different brands out there, but you've got to have something that you can clock this tank to where your top dead center line is exactly at 12 o'clock, at top dead center. Otherwise, when you put your firebox on and you go leveling the firebox by using the top of the door, which is what we will do, we'll run a level across here when we're putting our firebox on to get it clocked. If this is not exactly straight up and down, clock to 12 o'clock, and you put this on it straight up and down, now they're not going to be in sync, and you'll stand back one day and go, you know what, that just doesn't look right. And I see that happening all the time when guys will bring a cooker to me to be worked on for whatever reason, you know, someone else has built it and they want to change something. I can look at it and go, you know, did you know that your firebox isn't clocked right? And probably shouldn't do that, but I do. So we've got our tank clocked exactly 12 o'clock, and it is exactly level, and our tank is good and steady, so it's not going to cause us any problem. Our next step is decide exactly how high or low this firebox needs to go. I have for years liked to put my fireboxes through trial and error at 3 inches below the actual grate level. And in this case, our grates are going to the grate base. The grate bottom is even with the center line of the tank, which is obviously the entry of the door. The bottom door seal right there is the actual center line. Well, our grate material is 1 1/4 inches tall. So that means that our actual cooking grate surface is 1 1/4 inches above the center line of the tank. So we'll measure up 1 1/4 inch and put us a line there. And from that line, we will want to go down 3 inches. So 1 1/4 inches up here is going to mean 1 3/4 inches down from here. And that's going to be where the ceiling of our firebox is going to attach here. So let me go ahead and get some markers, and we'll start putting those layout lines in place. All right, so we've got 1 1/4 inches up, and we've just got a rough mark there. Of course, we have not put our center line on yet, our vertical center line on yet. We'll do that here next, but I'm in the ballpark there, and that's going to help us out. So I have not put the vertical line on yet. We haven't done that. We'll talk about that in just a minute, but I'm going to go ahead and measure my 1 1/4 inches up. And if I get it in the ballpark, I'll be able to get that exactly where I need later. And then I'm going to come down 3 inches here, which is, of course, 1 3/4 inches. Yep, double check that, to here. So this is going to be the ceiling of the firebox, and we'll make our cut right there. So we've got our grate level, and we've got our center line, and then we've got the ceiling of the firebox, and that's where we're actually going to weld it on right there. So our next step is to go ahead and handle this vertical center line so that we get this measurement right. Okay, so our next step is to get this center line, which is down the top of our tank, the top dead center line. If you'll remember back from the layout video, that's the very first line that we put on our tank, and arguably the most important line on this entire tank, since everything works off of that. What we want to do is to extend that line directly down the tank head or the tank end cap here. And that will give us our center line to align that firebox this way. So it's really easy to do, but it can get a little tedious getting the laser in perfect alignment down the top of the tank here. So there's a couple of tricks that I've learned over the years in working with these things to avoid some problems. Remember, we want to get the tripod with the laser on it perfectly aligned this way, but we also need to get it aligned that way so that it goes down the top of that line. And there are points later on putting this firebox on that we're going to need to lower the laser down here so we can shine on the firebox face, the door face, and basically put a center line on it as well. And when the laser is sitting down, this part of the tank will shade the top of the tank here. The end cap will shade the top, and also at various stages we'll have our little flange wizard on, and it will cast a shadow down the top of the tank and we won't be able to see our laser. So that's why I've put just a piece of sheet metal at the end of the tank, and it's just sitting in the collector. I'll bring you over in just a second and show you. This is just 1/8 scrap sheet metal out of the scrap pile. And I just set it in the collector and tack it in. And again, I'll bring you over in just a second. And then once I get it tacked in, I just put some lines. Once everything is lined up like it is right now, I'll just put some lines down it, some dash lines, so that later that's easy to see rather than having to try to look down the top of the tank. I know that probably wasn't the best way to explain that, but in essence, it's easy to get 3 points in alignment. A lot easier than trying to line up down the top of the tank. One being the laser itself, the second point being our top dead center ding right here. Remember at the very first of the layout, we used our flange wizard to put a nice dimple right there, and that will stay there forever. And then line up our white dash up there on the top. Those 3 points are a lot easier to get lined up with a laser than trying to work your way all the way down the top of that. And that'll become more obvious or more apparent in just a few minutes as we move a little bit further. So let me go ahead and tack that piece of scrap metal on, and I'll be right back and we'll move forward with getting these lines laid out. So I've turned all of the lights off and we can see that green line a lot better, and I've even put some little white dashes on just for the camera's sake, on the black Sharpie mark that I had as the center line, and went ahead and measured up 1 1/4 inches to the actual grate level, and then down 3 inches from that to where the ceiling of the firebox is going to be. I put marks all over these tanks so that I don't do something by accident, because I get busy and doing whatever else, get distracted and I'll get confused. So I mark everything so that I don't accidentally put that firebox somewhere else. Also, we talked about the little dimple at the top of the tank, which is the center line, and we'll shade that laser light so there it is, you can see that there. And then the top dead center line all the way down the top of the tank there. And I'm going to go ahead and put this back in place and get it in the dimple there. And now you can see how that line goes straight through the center. I'm shadowing it there. Straight through the center of that tool. Goes all the way to our piece of sheet metal at the very end down there. And I have tacked that in place there on either side and down in the bottom, of course. And there's our little, I don't know if you can see it there, but it's right there. It's pretty easy to see for me, but looking through the camera, it's just not as obvious. So that just makes aiming all of this a lot easier or moving through the next steps of doing this process, and you can see how now all three of our points here, the laser, if I could hold it still, the laser, and then our flange wizard, and then our piece of sheet metal with a little white mark on it at the very end. Aligning all three of those now is extremely easy. So now we'll move forward and start situating the firebox in place. Okay, so I've put the firebox against the tank, and it looks like it's in pretty good alignment. I see that my top dead center line, which you see my two dings on top of the firebox, we put those in an earlier video when we built the firebox, and join those by a straight top dead center line, just like the one on top of the tank. And it is in alignment with our vertical line here. And I probably ought to go ahead and put some, make sure that I'm correct. Yep, I'll go ahead and put some lines here, just so that we have those in case that tripod gets bumped by one of the dogs. There we go. So there, it's on there. So all of our lines line up and everything looks good. And if you stand back and look at it, it looks like it's in the center of the tank because it's just hard to tell if it's not. But there is a problem though. If we put our level on the top of the firebox door, we see that it is wildly out of level. The bubble is way over here. So something has happened. And if you're not careful, you won't notice that if it's out just a little bit. I greatly exaggerated this when I set this little clip up so that you could see it. This door is obviously not level. So what has happened is the tank is over this direction too far. Although this is lined up, since the tank is over, it's rolled in a position to make that line up. So what we want to do is push the tank over in a position, and also in the position where these line up, and also make sure that our door top is perfectly level. And that is going to be right in there. The top of my door is exactly level. So now I want to move the tank in position, or excuse me, the firebox in position where it matches the tank. So now these lines are lined up and I am level. And I'm not going to go to the extreme to get that done now, because I'm going to hang this from a sling here in just a minute. There's no need in getting it exactly right, but I think you understand what I'm talking about. Not just make sure this is level, also make sure that your door is level before you tack that in place up here. And we'll go through that in a minute, but it's just harder for me to turn it and move it around to demonstrate this error if it's hanging from the sleeve, because when it's on the sleeve I won't be able to twist it that much. So I think that's pretty straightforward. Not only make sure that you're lined up this way, also make sure you're lined up that way, and the way to do that is to make sure that you're still level, because if it's pulled to the side one way or the other, you have to roll the line back to get it in alignment. I hope that makes sense. All right, so I've still got the lights down, or I turn the lights down, and let's move our firebox pipe into position. Now, the most important thing, again, I know I keep saying this, but it's very important, is to make sure that that door is level. And in this case, you can see that it is pretty darn level there. Next, we want to make sure that we're semi-level in this direction. That's not that big of a deal here, because we can fix that once we put our weld here. So what I want to do is get that lined up in this corner right here, and make sure that we're semi-straight going down this line. Get it lined up pretty good. Again, that's not critical because we can adjust that a little bit once we get our weld done. But again, most importantly, make sure that that door is right. And we're in good position. I'll grab the welder, tack that real good, and then we'll start fine-tuning and tweaking it. This works better if you got another set of hands, but no big deal. Again, before I start tacking, just going to triple check. Yep, we're good. Move up to our line. Just a little bit of pressure on it to hold it. And that'll hold it in place while we triple check everything. Again, I think you can see that we're pretty good going straight down our lines. I'll turn some of the lights out. And we're perfect alignment coming all the way down. We are on our bottom line, not our center line or our grate line. And door level is dead on the money. So we are good to go there. And I'm going to beef that weld up a pretty good bit so that we can put a floor jack under the back, and this will hold this in, and we'll get all of this strap out of the way. We won't need it. All right, a quick look at what we have, and that looks pretty good. All right, so we've got our floor jack in place. I haven't got it leveled up yet. Just kind of glance at that, see what we look like. It could come up just a tiny bit in the back, but it is holding the weight, so let's go ahead and get this strap out of the way. And we can come up just a tiny bit in the back. Make absolutely sure that your level is on that center line right there. And that's darn near perfect right there. Okay, so we're ready to draw our line here. In other words, mark where our tank needs to be cut to accept the firebox so that the firebox can slide in. That's the tricky part. That's what we've been doing all of this to arrive at. So the question is, how do you do that? And in my experience, the best way to do it is to make yourself a little tool. This is just a piece of, and I'll try to hold it still so the camera will focus, a piece of 1/4 inch wood, stick. You could use a yardstick, would be fine. I have plenty of this scrap laying around, so I use it. And I tape a piece of chalk stone to the end, and I have on my sander ground the little thing to a sharp point. It's important that the point matches the bottom of your stick. In other words, when you set it on the tank like that, the line corresponds with the bottom of the stick, like so, so that you're drawing the exact top of your tank, your firebox pipe there. And we're going to slide it down. Now, another problem that guys are just getting started, and I've seen them get mistaken, is they won't follow this stick down perfectly level. So a little tip there is just take your marker and probably about the 6-inch line or something like that. When I was newer at this, I would do lines a little closer together, but just put you a little 6 right there, and maybe a 9 right there, and then a 12. And over here, do the same thing, like a 6, a 9, and a 12. And that way you can kind of eyeball as you're coming down to make sure that you're hitting these lines timed when they need to be hit, if that makes sense. So, and I actually put those a little bit too far back, so I'm going to move those up just a tad. And like I said, I've done it enough that I don't even need these little guide marks anymore, but we're going to put them on here for the video. 9 and 12. There we go. That way, as I move in, I can still see this line, because this stick is going to have to move way in as we come down here, if that makes sense. So let's go ahead and make that mark. It's super easy to do. Just make sure that your chalk is not curved up. It's actually marking the top of the firebox pipe. Get your stick in alignment there and just slide it down. And as I'm sliding, I'm going forward as well because of this compound curve. I'm having to go in the whole purpose of having to slide this stick, and I'm watching my little lines here to make sure that I'm staying straight, and I am. And I'm watching this distance to make sure that it grows at the same rate on either side, and just gently work this all the way around as far as you can go. And I'm about an inch before the weld over there, just where I want to be. So I'll go to the other side right quick. Okay, the next step is pretty straightforward. All we need to do is cut this line, and we're going to cut it just about an inch before that weld on either side. And the reason I stop about an inch before the line is if I need to adjust this firebox pipe just a little bit one way or the other, I may have to cut a little bit further on one side than the other to get it perfectly straight. Now, I've never used the whole inch. The most I've ever had to use was like a 1/4 of an inch, and that's a lot. But I don't dare want to have to run out of space to where I can make some adjustments in case this cut goes, you know, kind of weird or whatever. That's a super rare case, but I'm just too scared to get too close to that line because I don't want to cut into that weld, if that makes sense. So I'm going to stop about an inch before the weld. And I use plasma cutter for this. This is the only step in cooker building that I use a plasma cutter for. I could do it just as well with a torch. Just, you know, plasma cutter is going to be a little bit cleaner, not a lot, but a little bit cleaner, and it's easier to get out and all of that. It just is what it is. I could do just as well with the torch and not have to use plasma cutter. I use the plasma on a lot of other jobs that I do, not having to do with cookers. So it's out and it's easy to get to. It's quick and it's clean. If you don't have a plasma cutter and you're just building cookers, I would not, in my opinion, I would not invest the money in a plasma cutter. A torch is far more versatile. You can make these cuts, you can make thick cuts. My torch will cut up to 7-inch material fine. So a torch is just so much more versatile. But if you've got a plasma cutter, you know, this is about the only place that I do it. I wouldn't dare use plasma cutter on the doors for reasons we've discussed before in cutting the doors. That's just too much heat to go into there. So let me get started and we'll go ahead and make these cuts. Lila, go over there, baby, go. Come on, go, go, go. And make sure you cover your feet. The slag off a plasma cutter is very, very hot, and it will scroll right through your tennis shoes and a lot of times even your boots if you've got boots on. I don't wear boots anymore. I wore them for so many years. I can't wear them anymore. So anyway. All right, so that's our rough hole. It looks pretty good. I came just to the edge of the white line all the way around, and I even took, well, there's one spot that I may need to go a little bit further, but we'll fit the pipe in and see what it looks like here in just a minute. Again, what we want to do is just cut with the plasma or torch or whatever you have to use. Now, I don't know if I mentioned, I don't think that I did, You can very easily make this cut with an angle grinder and a very thin disc. Just do it in 4 or 5 passes, light passes, and it'll make those turns. Just be careful that you don't bind the disc, you know what I mean? If you do, it'll just break the disc. Make sure you use good eye protection and all of that business. And after, if you use a torch or the plasma cutter, I just spend like, I don't know, maybe a minute and a half, 2 minutes max, go through, knock the burrs down or the little bit of slag that may be hanging down, and then do a test fit. You don't want to get shaping a whole lot at this point because you may not need it. It always surprises me how little shaping I need to do. So let me grab the tank or the pipe. And we'll cross our fingers. And that's a pretty darn good fit. Let's look. There'll be a little bit of shaping that needs to be done. I need to take just a tiny bit off here. Well, you know, I could fill that with a welder, no problem at all. I mean, that's not a big deal. But I think that if I take a little bit off right there, it's going to let this come, it's going to close this up, and maybe even take just the tiniest bit between here and there, and that's going to let it come up and fill that. That's not even 1/8 of an inch. It looks thicker down there than it is because of the shadow, but it looks pretty darn good for the first fit up. So we'll massage that just a little bit and get it darn near exact here in just a couple of minutes. That looks pretty darn good right there. I don't know how we could get any better than that, so let's leave that alone. Okay, so at least according to the inspector here, all of our lines are lining up with the laser pointer. Our target lines here, there, and up on the other end there. Our tank is in position, or at least our firebox is in position on the tank where it needs to be. We're happy with that. And now it's time to mark the inside of this firebox pipe so that I can cut that out. I did not add that in an earlier video. I just didn't. And a lot of guys over the years have been leaving their firebox intact and just suffering through a huge hot spot that generates right here, and they can even miss out on some advantageous, or at least some advantages of cutting that section out if you don't do that with the way of flow. So let me explain real quickly what's happening. In this universe, of course, hot air rises, and hotter air rises faster and stronger. That is the golden rule that we keep in mind whenever we're designing a system or even cooking on any system that we have. Hotter air will always rise to the very ceiling and compete with a less hot air, and this column of air moving through this tank from the firebox to the collector side will be a horizontal column of air based in gradient levels on temperature. So the very hottest gases will occupy the very top, the less are hot, and then we will be cooking in this Goldilocks zone down in here. So the same happens here. The superheated gases will accumulate in the very top of the firebox. They will flow into the cook chamber and immediately shoot to the ceiling. And the idea in this case, for what we're doing now, is to allow those gases to flow right up this tank head wall and then make this gentle transition and flow across the ceiling. A hemispheric tank actually works better because you've got a more gentle slope, and those gases will more gently come up here, make this transition, and they will have less of a bounce right here. This tank will cause just the tiniest bit of a bounce right there. And of course, when those superheated gases, that layer will be about that thick, when that layer bounces down, the layer below that bounces down, the layer below that bounces down, and you will get some hot zone right in here. But it's not near as bad on a hemispheric tank because you don't get as much of that bounce. So let me pull the camera over here where we can see from the inside and see exactly what's going on. Okay, so I think that we can see what we've got at this point right here. This is obviously the firebox ceiling right here, the tank head wall. And again, imagine the grate, which will be sitting, here's the edge of the door, it'll be sitting right there. So that distance is about 4 inches. That's not enough for all of those superheated gases to come out and flow up and get away from our grate. The superheated gases will come out, the lesser heated gases will be bouncing or traveling directly through our grate. And if you happen to put meat there, it's going to get destroyed very quickly. So let me grab a tape measure and see exactly how far that is. Put our little stick up here, and that is 3 inches. So we have 3 inches for the gases to flow up, because they are going to. Nothing we can do about that. 3 inches for those gases to flow up before they hit our grate and before they start flowing through the grate. And that's what happens to about 90% of the gases. They will flow directly through the grate, causing us a huge hot spot here, and over time even burning that expanded metal. So it makes a whole lot more sense, at least in my mind, to go ahead and cut this piece out. And even if it's an insulated firebox, you could cut it out and then just put some, stitch some pieces in there to cover the insulation. You'll be fine. As a matter of fact, when I insulate them, I build the system exactly like this, and then I just put the insulating shell, slide it up on the outside exactly like I've done this, put some spacers in there to hold it in place and go from there. But a lot of people do it different ways, and there's absolutely nothing wrong with doing it different ways. But in most of my cookers, the fireboxes are not insulated. The people don't have a safety issue that they're worried about, small children or cooking in the public or something like that, so they prefer to run non-insulated. So what I'm going to do in this case is just put a mark all the way around this firebox where it matches the inside of this tank. And again, it's lined up exactly perfect where I want it. And then I'm going to come off of that line about 3/8 of an inch, just enough to give me a good little surface to stitch weld to, and ultimately I'll put like a 2-inch stitch weld scattered every 2 inches through there just to hold. Of course, it'll be welded completely on the outside, so structurally there's not going to be a problem. If I put a weld on the outside of something, I also like to put at least a little bit of stitch weld on the inside. That's just me. I'm sure it's overkill, but that's the way I prefer to do it. So if we decide to cut that back, let's see how much room we have for those superheated gases. This is simulating, this is going straight across to right there. So this is simulating our grate, the edge of our grate. That's 12 inches. So 12 inches versus 3 inches for all of those gases to get sorted out and make the transition to come across the ceiling. Now, a lot of guys that are running this system, running like this and have the 3 inches, they'll put a deflector plate in right here so that those gases come out and they're deflected up and away from the grate. That's okay, that works, but you have to understand that there are problems when we do that. Whenever we put something in the way of flow, we are disrupting that flow, which is called turbulence. And in this case, this deflector plate, no matter how you angle it, because I've tried it every way from Sunday. I've even put plates in there with slots in them, holes in them, spaced it apart. I've done all different kind of ways. I have even put slots in the top of this, round holes in the top of this. I've tried everything. In my experience, the best thing to do is cut this completely out, and you avoid all of those problems that come with the turbulence of a deflector plate or the turbulence from putting slots in here. What we want ultimately to happen is those superheated streams to get to the ceiling of this tank as quickly and calmly as they can, go over to the collector side, get pulled down by the collector, and then up the stack where they're doing their job, creating draft going up that stack. So if you put a deflector plate here, just understand that at the top of that deflector plate, the top and behind, you're going to create a low pressure zone, and that low pressure zone is going to create an eddy which will pull some of those gases back down. So if you're pulling the 300 degree gases back down, you're pulling the 400, you're pulling the 500, so you'll get a bump coming back down. So if you do have a deflector plate and you notice this area is kind of cool, but this area here is a little warmer or a good bit warmer, that's what's happening. You're getting basically a Bernoulli effect, which is, like flaps on an airplane, changing the shape of that air flow there, and you're creating a low pressure zone here, which pulls that back down. So probably a little more information than you ordered there, but if you're interested, there it is. That's what's happening, and maybe one day I will show a video where you can actually see this happening. That's probably a good idea for a video. Just occurred to me. I'll need to write that down. So I'm going to pull this back out and cut about 3/8 of an inch in, slide it back in, make absolutely sure it's where I want to be, and then weld that thing in place. Now, if you have done all that and you save this piece, if you don't like it, you could just tack the thing back in. You don't have to have an airtight seal around there. It's not going to make any difference. Or if you're like me and you want to experiment with all different types of shapes, you can put all types of baffles and deflectors and all kinds of business in here. So getting that thing out of the way, in my opinion, is a huge advantage because it gives you so many more options. If you want to go back to what you got, slip it back in, or slip a shaped piece back in that maybe an 1/8 inch thick or something. It doesn't have to be super thick. All you're doing is deflecting air. So that's my recommendation and the logic behind it. Okay, so we've got the firebox mounted and everything looks real good with that. The next step is going to be adding the back plate to the firebox, and while we've got the tank rolled over, and if you don't have a build table, I would encourage you to build something that you can roll the tank with. You'll see in this next step that that's a huge advantage, being able to get this tank up where we can actually deal with the parts that we need to deal with up here rather than laying down upside down, and it's a lot safer. You do a lot better job and it's a lot safer. So we're going to spin this tank, and there are a couple of tips here that a couple of safety tips that I need to talk about. One, have some tabs ready to go. We can knock these off later on. You can put tabs anywhere you want. It's always better to have too many than not enough. And I've got a safety chain ready to go. So when I roll this tank up, you'll see that eventually it's going to get way up here, it being the firebox, it's going to get way up on top, and at some point it will actually start rolling the other way, and that can be a very, very violent affair if you do not have something to keep it from going over the top dead center mark. Ask me how I know about that. I went running one way, the dogs ran the other way. We're all screaming bloody murder, and luckily nothing got hurt and nobody was killed. But the lesson from that is always have a chain ready to stop. Now another tip is, you notice this is my tank stop or my micro adjust tab here, and it's about center line with the tank. Not exactly, but it's about center line. Well, we don't want to lift when we're rolling the tank over with a firebox on it from over here, because it will actually pick this side of the tank up. The firebox is so heavy that it will counterweight it back in that direction. So with this 345-pound firebox, we need to get a tab further down and closer to it. And it's always nice to have our skate, which is this part here with the wheels on it, kind of looks like a rollerblade skate. That's why I call it a skate. It's nice to have this piece all the way to the end if we can. Of course, you don't want it so far that it interferes with the swing of the firebox. That's kind of aggravating to get it fixed and then find out it won't work. So it's going to ride on this band area right up in here when it comes around. I don't know if it's actually going to be on the weld or be on the band, but we'll see when it gets there. Doesn't really matter as long as we clear that hinge right there. So I'm going to swing it on up, get up close to the top, probably 11 o'clock, 10 o'clock, 11 o'clock, and then we'll start inching closer using a safety chain just to prevent it from rolling over that way. Of course, the crane's going to keep it from coming back this way, but we don't want it to go past that top dead center line. Oh, and another tip, our doors are locked down real good. We don't want them to clank open when it goes the other way. So make sure you do that. Also, it's a good idea to periodically or have someone else check the other side to make sure that you're not going to hit a hinge or some other obstruction. And if it does get to a point, whether you're using an engine hoist or a tractor or you know, a gantry crane or a jib crane like this, if you hit a point to where it's a little bit hard to move, stop. Because some of these winches, this one's a 4,000 pound winch, it will straighten out those hooks on the end of my chain and I won't even know it. So just be careful. And I'm going to get back on the other side for safety, obvious safety reasons. I don't want to be chased up against that wall. And at this point, I'm going to start using a safety chain to go down. And I'm just going to give myself a little bit of slack, and I'm going to move a couple of inches at a time. Door, or at least check the bottom of the door. And sure enough, we've got just a little bit more to go. And that is it. We're there. All right, so we've got our tank flipped completely over. That's pretty straightforward. And always make sure that you're using a safety chain. I've got one on either side. And until recently, I was using a strap to hold the tank in perfect alignment when it was upside down. When it's right side up, of course, we would use the micro adjust or the tank stop to do that, but obviously it's not going to reach here. And using a strap is very cumbersome. If you've ever done that before, you know how you go to move it and you get it exactly right, you go to tighten it down, and then it kind of moves the tank a little bit. And then it just occurred to me to just use a couple of short pieces of chain and a turnbuckle. Just grab that from the hardware store and put one on one side, one on the other side, hooked onto one of the safety tabs, and wow, it solved the problem. You can give just the tiniest bit, a little turn on either side, and shift this tank and micro adjust it. It does a fantastic job of getting it exactly clocked perfectly. So, and another tip is, remember when we put the firebox on, we registered or clocked the tank using the top of the firebox door. So from here on out, whenever we are clocking the tank, we want to use that firebox door top. So come around here, of course it's going to be on the bottom now because it's upside down, and we are clocked exactly right. So the tank is in perfect position. It is leveled that way and it is clocked exactly right. And that's going to be very important when we're putting our feet on, because we want the feet, which are going to be about like this, we want them to be in the same plane with each other this way, and we want them to be level with each other going that way, if that makes sense. It'll make more sense when we get going, but very important to get this tank leveled this way and clocked exactly right. Now the next thing we need to do real quickly is make our little cardboard template. And what I would do is just get an oversized piece of cardboard. It can be rectangular or square or whatever, and just kind of slip it down behind like that. Imagine this piece being oversized and square. Just kind of slip it down behind and let it slip all the way down in there, and then just take a Sharpie and mark that spot, mark that arc out, and that'll solve that for you. And then cut that out with a pair of scissors. Bring that over, get it in good position. Of course, we're still going to be square or rectangular all the way across there. Mark the back of it with a Sharpie, cut it out with a pair of scissors, bring it back, test it, make sure that it's exactly the way you want. And then we'll take this over to the welding table, put it on top of a piece of 1/4 inch plate, trace it out, cut it out with a plasma cutter or torch or whatever you want to cut it with. Grinding cut-off wheel will be just fine. It'll do that. It'll make that angle. And then we'll bring it back over here and start massaging it into shape. We'll tack it into place, grind down or sand it down to where it matches that profile exactly right. Pull it back, pull our tacks off, pull it back off, and then bevel this edge. Well, this edge is already beveled. We did that in the previous step when I made the firebox. And then we'll bevel the inside of our piece of plate, weld it up, and we'll be good to go. And we'll start with feed at that point. So let me get over to the welding table and start cutting this piece out. Okay, so I've used the pattern that we saw earlier to cut out the 1/4 inch piece of plate, and it's pretty close. There's a couple spots that's probably a 1/16 or in some spots maybe even an 1/8 higher than the actual pipe. So what I'm going to do now, I've tacked it in just one small spot here and one small spot on the other side. And what I will do now is just take my 4.5 inch grinder. I used to use the big 9 inch, but that thing's just too heavy for me to pick up and handle now. So I'll use the 4.5 inch grinder, and I will put a 36 grit sanding disc on and bring this down to where it matches the contour of this pipe exactly. Doesn't take just a very few minutes to do that. So let me get that done, and I will be right back, and then we will cut these off and put our bevel on. All right, so you can see that I have smoothed that down to where it matches this profile, and I've put my bevel on this piece already, my weld prep bevel. So this piece is beveled and that piece is beveled, so I'll go ahead and weld that up. Of course, fill that V up with weld all the way around, and we'll be clear to move on to doing feet. All right, so that wraps up this episode for attaching the Firebox Joinery video. I think it turned out pretty good. The fitment looks really nice. The welds look okay. And there was one little tip that I would, or there is one little tip that I would pass on here. I don't know what I was thinking, but I failed to weld the grease dam in before I attached the firebox. That would have been a whole lot easier to do when this tank was rolled over, right side up, and I could have sat here in a chair and actually welded this little piece in. Of course, it will get cut there, and that's the radius of the tank. Now, you can get the radius of the tank from your open door. Just take the piece of flat bar and a Sharpie, and then put it on the door opening right there, and you can get the curvature or the radius of your tank. And I weld them in just before on the inside of this vertical seam weld right there. That's a mechanical weld where the pieces fit together like that, and there's a nice little area that you can weld that in. Of course, it'll be up here, sitting like that, to stop grease from pooling and then ultimately flowing down into the firebox. That's not something that you want to experience, is a firebox fire and then the whole system catches on fire, and it's basically a nightmare. You will lose the cook. So pretty quick little tip. It's not going to be that big of a deal for me to reach in and weld that in. After we get the tank rolled right side up again, I'll have to come through one of the doors and reach way down in there. I've done that probably 50% of the time. I have no idea why I forget to do that, but I think it's a matter of getting excited about being done with the Firebox Joinery, and I just forget it. So that wraps this episode up, and if you were able to get some good information from here that helped you out, give the video the thumbs up, hit like, and certainly pass it on to any friends that you think could benefit from the video. And if you have not subscribed to the channel yet, if you'll go ahead and do that, that helps me out tremendously. It moves the video up in the rankings so that more people are able to see it. A little quick house cleaning. And I've had several guys over the years, a lot of guys over the years, have said, Mike, why don't you do a Patreon channel so that we can support you and help you create these videos? And that's just not me at this stage of the game anyway. There is a way that you can support me if you want to. You can go to the mysticsmokers.com website. There's hinges, there's handles, there's everything that you could possibly need to build a a cooker, and that comes directly to the Mystic Smokers business, so that's a good way to help us out. And I will see you in the next episode. Thank you.